All right, we are going to begin the next unit, which is going to focus on one of the parts of the atom, which is the electron. So last chapter we focused on the atom, which talked about protons, neutrons, and electrons that are found within the atom. Well, this chapter we're going to zoom in even closer, and we're going to focus on just the one subatomic particle, which is called the electron. So the model of the atom has evolved over time. So we know that right now the protons and neutrons, so we know it again, it's evolved over the time. So we know that right now we have protons and neutrons, and that we know that these are found in the nucleus. And then we have our electrons, and our electrons are going to be found in our electron cloud. So they're floating outside of the nucleus in what we call an electron cloud. And again, this is what we're zooming in on for this chapter, is that electron cloud. So in previous classes, you may have heard about a model called the Bohr's model. So the Bohr's model technically is not correct. So this is the model that is widely believed and widely used. However, his model shows electrons in these specific orbits, but that's not really where they're found. They're found more in what we call an electron cloud outside of the nucleus. So his model is not really it's not really correct. And so this was discovered through scientists in 1920. So again, scientists in 1920 came up and decided that, yeah, the electrons are outside the nucleus, but they're not on these specific rings. Instead, they are, so again, he's saying these electrons are here. So instead, they're more so just in an electron cloud outside of the nucleus. So again, we're going to be focusing mainly on these electrons in the electron cloud. So electrons are really cool. So electrons have a great importance in the atom. So electrons are how we see light. So we utilize electrons a lot throughout our daily lives. Because again, electrons, these are how we see light. So why we see blue light, why we see green light, those are all the doings of electrons inside of an atom. So we're going to go through what our representation of the atom and how we're going to focus on that on the atom for this year. So we have our nucleus, which is positively charged because inside the nucleus we have protons and neutrons. Protons are positive, neutrons are neutral, meaning our nucleus is positive. Then outside of the neutron or the nucleus, we are going to have our electrons. So we're going to have our electrons in the electron cloud. I'm going to draw based on Bohr's model just because it's the easiest to draw, and it's actually a pretty good visual of what's happening. And each of these, however, what we're going to call are going to be called energy levels. So although these are really electron clouds, the cloud's kind of broken into these different levels. And this is called an energy level. Okay, you will also see these referenced as shells. So either be called energy levels or shells. We are going to represent that with the variable of n. So each energy level is represented by the variable n. The closer to the nucleus, the lower the number. So this energy level right here would be n equals 1. Then here we'd have n equals 2, n equals 3. So every energy level you come to outside of the nucleus, you go up by 1, and this can go on for infinity. So you can have as many energy levels as the atom needs based on the electrons. Right now, 7 is the most common. But again, these energy levels can continue to go on. Right now, because of the atoms and elements that have been discovered, 7 is the most common. So within each energy level, there are other components to it. So looking at this, we only see the energy level. But within the energy level, so I'm just going to rewrite energy level here. So within our energy level, we actually have what is called a sublevel. So sub meaning within, or so we have a sublevel. And then, so within each of these energy levels, there are sublevels. And then within each of the sublevels, there are actually what we call orbitals. And the orbital is where we're going to find a specific electron. So just so you guys can get a visualization of what each of these mean, so we're going to reference a hotel. So if we're looking and we're going to a hotel and they give you your room key and they tell you your room. Okay, well, the floor of our hotel, so they say you're on the 3rd floor. That is our energy level. Then they tell you what room you're in. So you're on the 3rd floor and you're in room 302. So the actual room, that's the sublevel. But where do we find all the people when they're in the hotel? In the hotel room, which is our orbital. And so within the orbital, we have a bed. And so the orbital is going to represent the bed. And so in the bed is where you're going to find the person sleeping. So you have the floor, which would represent the energy level, the sublevel, which is represented by the room, and then within that room you have beds, and those are the orbitals. And that is where you're going to find the actual electron in the atom. So every electron has a specific, if you want to say bed, or a specific orbital that it belongs to. Okay, so that's just a little background knowledge of the electrons, where they're found. So again, although we have energy level, that's just the floor of the hotel. It doesn't really give us a whole lot of information. But then we can go to what sublevel they're at. Okay, so what room are they in? That helps us know a little more about this electron, but then we can even dig further and go in to find the orbital. So we have then within each energy level, I just want to go through some of the letters again. So we have n equals 1, 2, and 3. So those are remember the letter variable n represents our energy level. The energy level that's closest to the nucleus, that is going to be what we call the ground state. So that is the lowest energy level that the electron is going to occupy. So the energy level closest to the nucleus that the electron naturally occupies. So for example, for this one, we can say an electron is in the ground state. So right here, this electron's in the ground state, n equals 1. That's the lowest energy level that electron will occupy. So now we're going to get into how do we see light. So it has a lot to do with this ground state. Again, that's that natural placeholder, or natural ground or state or ground energy level that the electron is going to occupy. But let's get into how we actually see light. So we're going to go to how we see light. So if you're driving and you see that red light that is telling you to stop, that is from electrons being absorbed, released, etc., which we'll be getting into. Okay, green light, that's going to be a different pattern of electrons. Then we have our yellow light, again, a different pattern of electrons. So the electrons go through this whole process in order to emit light. So the first step, okay, this step so we're going to call this step 1. And this step requires some sort of outside energy. So this is our step 1. So I'm just going to draw a rough sketch of I'll just draw 3 energy levels. All right, and we'll draw our electron here. So there'll be electrons everywhere else. I'm just going to focus on one electron. So the first step, again, requires some outside energy. And what's going to happen is this electron here is going to absorb that outside source of energy. So again, it's going to have to find an outside source, whether it's an outlet or electricity, but it has to have some sort of source of energy, and that electron is going to take it and it's going to absorb all that energy. And what we call that is the electron is getting excited. So when an electron is absorbing energy, it is getting excited. So that's our first step. Then we're going to have step 2. So step 2, once this electron, so I'm going to redraw this, 3 energy levels, so that electron that just absorbed energy it started at n equals 1, it now has enough energy to jump to a higher energy level. So now that electron is on our second energy level. So it is going to jump to a higher energy level. All right, so now it's at a higher energy level. So it went from 1 to 2. Okay, it's not going to be able to stay there very long. And so now that brings us to step 3. Okay, so step 3, the electron is going to drop down to its original level, which again is going to drop down to what we call the ground state. So it jumps up to what we call the excited state. So the excited state is the energy level that it jumped to. It's going to fall back to the ground state. When it falls back to the ground state, this is where something cool happens. And as it falls, the electron's going to go from here back down to there. So excited to ground. It is going to release our energy. So all that energy it absorbed from an outside source that allowed it to jump up to this excited state, well, it's going to fall back to the ground state and it's going to release all of that energy, and it releases the energy in the form of light. So it releases energy in the form of light. And it depends on what electrons are jumping and absorbing and releasing, which is going to give us our different colors. So certain electrons are going to give off red. Certain electrons are going to give off purple. And so that's where we're going to get our visible spectrum, where we're going to see our different colors of light given off. So again, just a really quick recap. So it's going to absorb energy. So it starts at its ground state, absorbs energy. It's going to jump energy levels. So it jumps from ground state to excited state. So here it's just getting excited. But it's going to actually here jump to what we call the excited state. And then it's at the excited state. It can't stay there for very long. And it's going to fall back to ground state. And it's going to release this energy. So as it falls back to the ground state, it can't have all that energy in the ground state, so it has to release it. It gives it off, and that's where we see our light. So light is the energy we see. And again, each electron can only emit certain colors because each electron is found on a different energy level, and each energy level represents a different amount of energy. The closer to the nucleus, the lower the energy. So n equals 1, that's going to have the lowest energy, where n equals 7 would have a much higher energy. So that's where we're going to get our different colors depending on where those electrons are jumping to and jumping from. So we can give off all of our array, so our Roy G. Biv of colors.